Welcome back, Math 2. Today we're working on page 129. We're going to talk about rational versus irrational numbers. And if you notice, this paper is blank. We're just going to be kind of drawing in some shapes and defining all these different types of numbers that we work with. So I think I want to draw the outermost shape first, just so we have an idea of what we're working with. So let's go ahead and get a nice big square. And here you can cover up pretty much the entire page. Get a nice big square in there. And then on the inside of that, you're going to draw one smaller square all over to the side, and then one just a little bit bigger square, because this square is going to contain a lot of squares. What is it? Rational. Okay, I think that's all we need. Yep, okay. So, your innermost square here, by the way, so we've got our big outer square, we've got our two big inner squares, and then we've got 1, 2, 3 itty bitty squares. So what this represents is all the different types of numbers there are, and the reason that it's squares within squares is because we're going to start on the inside, and as we move out, the next category is going to include something different, but it'll also include everything that was in the category before it. Okay, I'll explain that again as we're going. So this first category is called natural numbers. And the natural numbers, they're also sometimes called counting numbers, and I want you to think of all the way back to like kindergarten or preschool. When you were first learning how to count, you would count 1, 2, 3, and those are your counting numbers. So 1, 2, 3, those are the natural numbers, all the way up to whatever number you want, 394. Okay. But that does not include 0. Okay, so these are strictly positive numbers, whole numbers, all above 0. Okay. The next category out includes all of these natural numbers, and then it also includes 0. And these are the whole numbers. Okay, so the only difference is that it includes the natural numbers and it includes 0. So we still have not hit negative numbers yet. We're still in positive numbers. They have to be whole numbers, no decimals, no fractions, and we can have 0. The next category outside of that is called the integers. And the integers, first off, contain all of the natural numbers, all of the whole numbers, and now integers also include negative whole numbers. So -7, -24, but it can also include 0 and 8 and 29. Okay. So this is what you should be seeing. You should be seeing how each new category includes all the categories before it. And then moving on outside of the integers, the next category is called the rational numbers. So rational numbers obviously include all of these numbers before it, your natural numbers, your whole numbers, your integers, but they also can include fractions and decimals. Specifically terminating fractions terminating decimals where the decimal ends, like 0.25, or repeating decimals where the decimal repeats over and over and over again, like 0.33 squared. But it can include also these fractions, and they can be negative fractions too, like -1/5. But it also includes everything else inside those previous categories. In this other box, which you notice is separate from everything in here, instead of rational numbers, these are our irrational numbers. So rational numbers include all your whole numbers, positive and negative, and repeating and terminating decimals and fractions. The different thing about irrational numbers are typically that they are decimals that never end and never repeat. Okay, never end or never repeat. So an example would be the symbol pi. Okay, pi is used for finding the circumference of a circle. And pi will never ever end. It goes on forever, and there's no chunk of numbers that is being repeated over and over again. If you are in a science class, or when you get further into math, like Math 3 or pre-calculus, there's going to be this letter E. It's called Euler's number. And it is also another, it always goes on forever, and it never repeats. That is another irrational number. But it can also be when we try to take the square root of something that does not have a square root. So like the square root of 5. There is no square root of 5, and if I tried to plug that number into my calculator as a square root, I'm going to get a decimal that goes on forever and it never ends. Right? So these are our two different main categories that all fall under this one big large category called real numbers. Real numbers. Okay. And yes, that does mean that there are some non-real numbers that are not even within this category, and we will talk about them by the end of this unit, but for now, I just want you to know what all these different categories are. Okay, so the rational numbers include all of these things before. So if you're asked to list what the different categories are that a number falls into, if you want to say that something is a rational number, you also have to include whether it's one of these things, or rather if it's a natural number, like let's say you had to categorize the number 6. Okay, well 6 is all of those things. It's a natural number, it's a whole number, it's an integer, and it's a rational number. So there's a lot of things you need to include. But something like 1/6, for example, well, that's a fraction, and it is a terminating, or I think it's a repeating decimal. I don't remember off the top of my head. But since it's a repeating or a terminating decimal, it's just a rational number. They may ask you to include whether it's a real number or not, but for today, we're assuming everything we're working with is a real number. So this would just be a rational number. It doesn't fall into any other categories for us. These are all of our different types of numbers, and I'm sorry, I'll leave that in case you were still writing.